I am excited because this is where everything comes together. We are going to make, finally, Pong in Python. We've come full circle after today. That's a fun lecture to give. So let's take the pieces that we made from before. We got the ball bouncing around. We got the paddle moving up and down. All that's left is to hook them together and then also find a way to end the game. We need to lose the game as well. Or what we did in Scratch was we put that little bar on the side there. We're essentially going to do that with an if statement. Just notice if we ever hit that wall. So, yeah. By the way, everything that I'm doing today and recording is your last programming assignment. So your last programming assignment is to do exactly what I do today. And you can make it fancier if you want, but you will recreate Pong in Python following my lead. You can rewatch the video if you need to. That will be your last programming assignment. The one thing I won't do, of course, is give you the files that I work on today. That would be cheating. So you're going to have to at least rewatch the video if you can't type as fast as I do today. So, yeah, that is the setup, and I'm excited to teach you Pong. So let's do it together. All right, so what do we want? We would like our little screen drawn. We've got that. We've got plenty of code for that. Our draw rectangle function. I'll make this the squarest square that I can try to draw now. It'll take a few attempts probably. I should get like a ruler or something. But there it is. And yeah, we wanted to, we made a program that dealt with the paddle, right? We wanted to make sure that it didn't go out of bounds when it hit the top or the bottom. So we had code that made the paddle look like this and put it over here, and we stretched it. And we had to remember, okay, it can't go outside, and that has to do with the center point of this turtle, right? The center point of this square-looking turtle thing. Let's go to that code really quick so that I can show you those ideas. I'll need to be an idle one way or another anyway. But maybe what I can do is open up last time's paddle.py at least to start. And so this is the code that we had from before, the draw the rectangle, draw the bounding square, made the turtle the paddle. And we needed to keep track of where that turtle was. We'll put him over there so they can move up and down. And we don't want to go too far. And we had to watch out for that. It had to do with the magic number 140. And the reason for that was the size of that turtle. We stretched him. Originally, apparently a square turtle is 20 by 20 units in the turtle world. We stretched him by 1.5 on the x-axis and 6 on the y-axis. So that means our turtle became 120 in height. And so what we want to do, at least for the paddle, is to lock the x position and only change the y position, only go up or down for the paddle. And so the last point where we want him to be, at the top at least, this is our y equals 200 line, it's always relative to the center of the turtle, so really we don't want the center of the turtle's coordinate to be past this, and that has to do with half the height, right? So if he's 120 tall, that means 60 is half the height there. So that means y equals 140 for the middle of the turtle point there. That is what we don't want to exceed, okay? And so that's why we wrote that in our code last time. That's what we had here. It's all right, try to go up, increase your y by 10, but if we went past that magic number 140, that was too far. And just make sure to rein it back into exactly the tippy top there. Okay? So yeah, that gave us this. I'm pressing it, I'm holding it in, it's not doing anything. And same for the downward direction. Have the same idea, and it's negative 140. We don't want to go past that for our y position. Okay? Because this is the line y equals 200. He's 60 tall, 60 units tall, so that's negative 140 is the center there. We don't want to exceed that. Does that make enough sense? Do we remember it from last time? Any questions about that stuff? So that's fun. So you have that code, of course. Let's make a new file for today. Again, I'm not going to give you the file because you're going to recreate it, but I'll save it somewhere. Maybe I should save it in the CSCI 1 folder so I can look at it next semester. I'll call it pong.py though. All right, this is where it lives for me now. But I'll copy and everything like that. And so now we have the paddle program. just the paddle program, and we need to add the rest. So right now my pong.py looks like this. There it is. So yeah, the next piece of the puzzle is to add the ball back in. Okay. So that is actually going to be a little tricky because if I go back to, here's the paddle program right now. If I go back to the bouncing ball 2D bounce program, remember this one? Let's remember what this looks like. So ball bouncing in weird random directions, that one. So this program, what did I do to make this ball? Oh no, the turtle was also the ball, right? Make the turtle the square. That's the idea. Okay, so if I have the turtle be the ball, and I also have the turtle be the paddle, I am a little stuck. You see that? That's a bit of a problem right there. So we'll have to fix that somehow. Well, let's see. Where do I want to go with this? So, all right, the turtle is the paddle, but the turtle also needs to be the ball. The answer is you can have multiple turtles in your turtle program. We've never done this before, but now's time to learn. So when we said turtle.stuff, turtle.goto, turtle.forward, turtle.listen, all those things, all those fancy things, that moved what's called the default turtle. Every time you import the turtle library and you use the turtle library, there's at least one turtle that gets made on the screen. We call that the default turtle, and that's what these turtle.things give to you. Extra turtles, if you want more turtles in your program, you make a variable for those. So here's essentially what we need to do. If I go to the documentation page, it should be more or less apparent. There's a way to make a new turtle. These are all working with the default turtle, but it's turtle.turtle. Oh gosh. Is it capital turtle? Yeah, it's capital turtle. E. I don't know if they're, yeah, it's not really explaining it very well. I promise it's here, but like this example, for example, see how somebody's saying turtle and they're assigning it to a variable? That's what we're going to do here. We're going to say turtle.turtle function. If you call the capital turtle function in the turtle library, that creates a new turtle which you can place somewhere. You can call that paddle, for example. And then paddle is the name of that turtle you'd like to talk about. You can make a turtle called paddle, you can make a turtle called ball, and then instead of saying like turtle.goto, you'll say paddle.goto. You've given a new name to that new non-default turtle. All right, so now we'll say paddle.whatever, goto everywhere instead of turtle.goto. All right, I hope that makes sense. That's what we need to do. The key presses can still be listened for by the default turtle. Like, that's a fine thing to do. But everything else, we have to switch over to have multiple turtles. All right, so let's get this original, just the paddle program, working with a turtle called paddle instead of this. Okay, so this first part of the program was like drawing the bounding rectangle. That's fine. Let's section off our program. We're going to do some paddle stuff, right? So we make a very long section header here. I'll carve it out. It's like paddle stuff. All right, paddle stuff here, and then we'll also have ball stuff down here eventually. Okay. So that's how I'm going to section off the program. And now, it's not make the default turtle the paddle, it's make a brand new turtle to be the paddle. So I'm going to say paddle equals turtle.turtle. That's how I'm going to do that. So, what should I change this comment to say? Make a turtle, not the turtle. Make a turtle for the paddle. Okay? So that's what I'll do. I'll say paddle equals turtle.capital turtle. That function creates a brand new second turtle in the screen now. And so now we have a brand new turtle that we can talk about using the paddle variable instead of saying the default one. We'll say paddle dot whatever. Now we say paddle dot blank all over the place instead of turtle dot blank. All right, so now not turtle.shape, but paddle.shape. That particular turtle needs to become that one. That particular turtle's fill color should be purple. That particular turtle's size should be stretched in that way. Okay, so that's that. These are still variables that are fine. Pick the paddle up, paddle.goto, 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 and then the default turtle can still listen for the key presses. That's fine. It exists. It can be handling those things. It can just command the paddle turtle because it knows its name now. All right, so that's what I've changed. I've made a brand new turtle here for the paddle, and then I've told that turtle to do stuff. And it all should still mostly work, right? Draw the rectangle, and then that was with the default turtle. Drawing that rectangle, and then I'm doing paddle things with a brand new turtle on my screen. Okay, so if I save and run this, I get that, which is not quite right. It's a little bit sideways. So funny enough, the reason it worked before is because we use the default turtle. You see the default turtle right here? It didn't become this now, it's a second turtle. But he was facing straight up. And because we stretched it in that way, when he was facing straight up, he became the paddle, longer than he was wide. But the default turtle, or sorry, the default paddle, the new paddle that we made, not the default turtle anymore, but the brand new paddle called paddle, the default direction, that's what I'm trying to say, the default direction in any new turtle is always facing east. See that? So he got stretched, but kind of in the wrong way. So there's a couple ways to change that. You could stretch differently on a different axis maybe, but honestly what we could do is just like make that turtle turn 90 degrees. So I think that would be the easiest one. Like make him look like that. He's facing right now. Make him face up. So what's the best way to say that? We can do, I guess, just at the start, after we, or even before we do that. Paddle dot turn to the left, left by 90 degrees. So that's going to face that turtle instead of facing right, face upwards like this old one was doing. Okay, and so that should fix that. Yay! And then everything else works as before, but we're using paddle.goto all over the place. That seems to be working. I do like this cute turtle, and the default turtle is nice and cute in the top left, but probably should not be there. There's a way to hide the turtle. We'll hide that default turtle now that we're not using it for anything else other than just listening for key presses. So there's one called, there's a hide turtle function. You can say turtle.hide turtle or HT for short. So let's do that. So after we're done drawing our bounding square and all that fun stuff, that original default turtle does not need to be visible, it just needs to exist, and it will, and listen for our key presses to paddle with. So we'll say turtle.hide turtle, and that hides the default turtle. Okay. So now after that rectangle has been drawn, the default turtle will hide itself. And then the paddle one gets birthed, and it's just going to chill right there. And so that's pretty much what we had before, now with a new turtle variable. Okay? So now that's nice, we can bring in the ball. Bring in the ball to the equation. So let's see, what do we want to say here? Yeah, the default turtle can still listen for those key presses. We were doing that. And then, yeah, let's copy in the ball program, and then I have some stuff to say there. Okay. So here's the Pong program. I got a spot for all the ball stuff here. So let's copy in the 2D bounce program into that. So the stuff that was in common, this was like the draw rectangle stuff, we don't need to include again. But all this stuff from like make the turtle the square, which is the ball, all the way down to like drawing the frame and stuff, that we need to take and steal down to here. All right. So I've copied and pasted all of that into ball stuff. And it was also, this program was working with the default turtle again. And so again, I need to make a new turtle. I'll say turtle.turtle and assign it to a ball variable. Okay, so now I have like 3 turtles in my program. The default one, the paddle one, and the ball one. Let's do that. Not make the default turtle the square, let's make it the ball. Make a turtle for the ball. Oops. That'll be the idea. Still square, shapes purple, stretched by that amount. But we're going to say ball equals turtle dot make me a new turtle, capital T. And so now, like the other one, now we say ball dot blank 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 all over the place to move this turtle and to do things with it. So it's ball, change the shape to a square, ball dot fill color, ball dot turtle size. Turtle width is just a variable. I should probably call it ball width. I'll mess with that in a second. I can do it now, I guess. Turtle X, turtle Y should probably be ball X, right? Ball Y, ball X offset, ball Y offset. It's worth it. Let's do it everywhere. Every time I said turtle, it's really the ball turtle. All that fun stuff. Ball dot up, ball dot go to ball X, ball Y. This is just a bunch of fixing. I'm sure there's a find and replace here, but it's not worth it. It's more easier to understand if I do it this way. Ball Y, ball width. Because there's multiple turtles, I can't just call it this anymore. That would be wrong. It would probably work, but it would be wrong. Morally wrong. So it's the ball turtle. Ball everywhere. We'll get there eventually. Ball X, ball width. Almost done. And so yeah, this is just for us really. These are just variable names. These don't really have to change, but it makes more sense when we have multiple turtles to call them like this. Let me change the, I guess we don't say change turtle X offset again. It's like ball X offset. I don't want to say this. Even in the comments. And yell at me if you see me miss one. Ball X, ball Y, ball X offset, ball Y offset. So close. I'm sure I missed one, and at least Python will complain and be like, this variable does not exist. And then it's ball.goto. I think that's what we want there. I think that was oh no, two more. So let me just check for the word turtle underscore is probably what I should be searching for. I believe that was changing all the variables. Ball go to. Let's not put the turtle in the right starting. Oh, did you see one? Oh, thank you. Oh, I see some right here. There's some. Were those the ones you saw? And even some more right here. You're right. Thank you. That's why we look twice, I guess. And yeah, if there's any more, it'll complain. But I got a third turtle on the screen now for all these bad boys, all this stuff. And it's working with those. So let's see. We can try running it. So everything's kind of separated. This first bit was for the screen, just draw the bounds. This part was for the paddle and how to move the paddle up and down and all that. The default turtle's listening for stuff. And then the ball stuff is a brand new turtle variable. Brand new ball. And it's moving up and down just randomly as we had it before. So let's see. Moment of truth. And the bouncing, let's make sure it hits every wall, checks every if statement. Oop, there it is. So it was the right wall's if statement. Something was wrong in there. There it was, turtle X offset. Python eventually notices. Alright, I think we're good to go now. We've got a ball moving around. I've got a paddle that can move up and down, and it's able to hit every wall and bounce off correctly. Cool. Nice. So the one thing I don't have right now is losing the game. Right? That's one thing I don't currently have. And then, of course, the big thing is the ball is not bouncing off the paddle because we're not noticing whenever that happens. Okay, so those are the last two pieces of the puzzle, really. Let's make them work. But are there any questions about how I got to this stage? This was like just bringing in stuff from before, trying to make it pretty and logical looking. Yes?
Go back to when you rename the turtle to ball.
Sure, this one right here. You say turtle.capital turtle, and that gives you something you can place into a variable. And that's your new turtle. Alright, and so yeah, you can change the color of each of these. They're all separate, right? This one's fill color was purple, the other one's fill color was also purple. Doesn't have to be. But that is, yeah, that's the logical separation of everything. And now the tricky bit is to link them together. Those are two separate programs we combined. Now they're working together. Now we have to have them influence each other. Okay. Maybe one nice thing, like I think we did this for the other one as well, for the Scratch version, but like it is possible for the ball to randomly start its life like way down here, very close to where the paddle isn't right now, and like you'd immediately lose the game, and like people might punch the computer if that happens. So I think what we should do is make sure the ball always starts its life on the right half of the screen. It could choose a direction that is leftwards, that's fine. We'll keep it like choosing any random direction anywhere, 360 degrees. But let's start the ball on the right half of that screen so that there's time to at least get the paddle over to there if it's going to move straight towards the left side. Okay, so that's another thing. Just to make it playable, let's start that ball on the right half of the screen, which means it's the x coordinate, right? The x coordinate of the ball should be somewhere over here. The y can be up or down, it could be up here, down here, but it should be on the right half, so the x coordinate should be 0 or bigger. This is the 0, 0 line in the middle here. So let's start the ball and make its x coordinate random, not between negative 150 and positive 150, but let's say 0. 0 and positive 150. All right, so that's, leave a comment to remind ourselves what we're doing here. So start it on the right half of the screen, or of the window. And now when I run the program, save, yes, you'll see the ball will still be randomly placed, but on the right half always, even if it's going to move to the left. And so that's going to give us some time to hit it. We'll see it in a new random place, but still on the right side. Still on the right side. So that was a simple change. That's not too bad. Let's see what next. Yeah, I think it might be easiest to do a game over right now. If the ball ever hits the left wall, it's game over. Okay, so game over should stop everything. All right, so let's. What I'm going to do is I'm going to notice when we hit the left wall. We have an if statement for that already, and I'm going to hook into that and say that the game's over if the ball ever hits the left wall, right? Because it should have hit the paddle and bounced off. So that is what I'm going to do. And so here's the trick, bounce of hit wall. Where's the one for the left wall? It's this one, right? If the ball's x becomes like too negative. If this happens, if we hit the left wall, don't bounce off. Let's change that now. If we hit the left wall, don't bounce off. So you can rein the ball back in again. That's fine. But instead of bouncing off, change the ball x offset so we move to the right now. This should go, no, we're done. So game over. What we should do is stop the game. All right, and how do we do that? How do we alert that we should stop the game? One way to do it, and this is the way I encourage you if you're ever going to make your own game, just make a variable that keeps track of if the game is still on. It's like we'll make an is game over variable and set it to true when this happens, right? It's very simple. But we're going to make a variable that starts out being false, right? The game is not currently over yet. So I'll make a variable up here called is game over. Of course, as the game starts, it's false, right? The game is not over, the game's playing. But then, eventually, it'll become set to true. And this is a global variable I'm setting, so just like all these, I have to say that. Global, inside of a function, I'm setting it. So global is game over. It's going to mess with that. And then, it'll be true if we ever hit that left wall. And what do I want to have happen when we hit that left wall? I would like essentially to stop the animation, stop the game from playing anymore, stop the ball from bouncing anywhere. And how does the ball bounce? Let's go back to that idea. It's essentially this draw frame moves the ball a little bit. So I kind of want to stop that. This infinite loop should stop if the game is over. And so it'll just look into that variable. So while the game is not over, essentially continue drawing the next frame. Okay? So instead of while true, I'm going to say while is game over is false. That's one way to do it. But the cool way using our logical symbols is instead of checking for it being while it's false, you can say while negating it is true. While it's not true, that is game over, right? While not is game over is a true thing. So while it's false, draw a new frame. See that? So that's what we're going to do. And the game is going to end very quickly right now because the ball, it won't hook into the paddle right now. So it'll hit the left wall, and then the program will stop because we're going to notice that. This is this code that's checking if we hit the left wall. If that happens, we're going to set this game over variable to true, and this while loop is like while it's not true that is game over, right? While it's false, right? Because not false becomes true, so that's nice. But once is game over becomes true, the negation of true is false, and so you're checking while false, that condition is not true, and so the loop ends when the condition becomes false, just like an if statement. It doesn't run if the condition is false. You can still move the paddle though, but I guess really it's just the animation for the ball that indicates the game is over. Any questions about that? So it's just make a new variable to track whether or not the game should be continued, whether or not the animations should still be happening. And so once we hit that left wall, we should stop. Okay. Let's see here. What else? I think the last real piece of the puzzle is make that ball bounce off the paddle when we're on the right side, right? The right side of the paddle, not the left side. So I think the easiest way to do that, the most logical way, was just like in draw frame, if we had a wall bounce off, let's make a function that bounces off if we hit the paddle. Let's make a function that's called bounce if hit paddle. Just deal with that as well. It's a very logical way to do it. It's a clean way to do it. So if we hit the paddle, bounce off, and then of course we have to go and figure out how to write this function. What does it mean to hit the paddle? How do we notice it? And then also how do we bounce off of it? We'll get there. So yeah, let's make that function. Def, that's the last piece of the puzzle really. Def bounce if hit paddle. So we have to notice that we hit the paddle, and we have to also bounce off of it. Okay? So let's figure out what we put here. That's the last piece of the puzzle there. All right. So this is probably the trickiest bit. Okay? How in the world are we going to bounce off the right side of that paddle? Let's figure. We have to draw a diagram. Okay? What needs to happen? It's kind of like the left wall stuff from before. The bouncing happens the same way. You negate the y part of your position, or the y part of your direction. That's still going to be the same. It's still the bouncing part, but just noticing when we hit this paddle is the hard part. All right. So here's the paddle, and what does it mean for us to have hit the ball? The balls are sitting right here. What does it mean for us to have hit it right there? It's all about coordinates. Right? That is going to be the hard bit. So we got a paddle in the game, we got a ball in the game. They're all referenced. We know where they are based on paddle x and paddle y. That's where the paddle is right now. And then ball x and ball y is where the ball is right now. Okay. So this is the middle of the paddle. That's what paddle x and paddle y represent. Tells us where that is. We're going to have to do some math. Paddle x, paddle y. Those variables give me where that is, that center point. And then the middle point of the ball, which is supposed to be a square. I know that's a little lopsided, but you get the idea. That is ball x and ball y, telling us where that is. Ball y. Okay. And then it's all right, are these two just barely touching each other? So this kind of distance is what we need to check for. Are they exactly that far apart? Because if so, they're touching each other, right? So that's going to have to do with x-coordinates. And like, what is that distance that should separate them if they're just grazing each other? It has to do with the size of everybody. All right, so we've got the paddle's size in the y direction, at least. The height of that paddle is 120, and then the width, we scaled it by 1.5. It's 30, and then this ball is 40 by 40. The width of that ball is 40. If you remember, we had that in the code somewhere. Like the ball width is 40 units. And so, like, we want, if they're grazing, if they're just touching each other, they better be offset by exactly that amount in the x direction. See that? What is that amount? This is going to be 15 there, plus another 20 from here. So it should be exactly 35 units away from themselves. See that? That means they're just grazing each other. So that's that direction. That's that amount to know that we're just hitting the ball there. Okay. So we need to know that, like that's true. The ball is touching the paddle when that's true. But then also we need to know something about the y-coordinate. This is stuff about the x-coordinate. We also need to know stuff about the y-coordinate because maybe, right, maybe the ball really is just grazing the paddle, but it's up here. Like the x-coordinates, like they have that distance, but we're still not touching the paddle, right, because the ball's way up there. So we also have to consider the y-coordinate. All right, so where's the highest point on the paddle where it could still be maybe touching the ball? You actually have some options here. Like you can consider this is the last place the ball could be for us to have hit it. Like just hit the tippy top there. But I think we should make it a little bit easier. I think this is what most video games do anyway. I think this should be the last spot where the ball gets hit. See that? You agree? Yeah. So that has to do with the y position. All right? The offset from the middle of that paddle, like as far as it could go up, would be up to here. And that is the amount that we need to figure out. And that has to do with the y amount. So this is 120 up here. So that's 60 up there, plus another 20. See that amount there? Because we're trying to get at, sorry, I drew this wrong. From the middle of the paddle to the middle of this ball, that's the offset that we're trying to figure out. So like we want this y amount. What is that amount there? It's wherever the paddle y is, plus half of its height, plus 60, plus 20. See that? That's a little disgusting, but that's the idea there. And then same for the bottom. Like the lowest point where the paddle should be allowed to hit the ball should be down here. And that's going to be, again, like what is the coordinate? Like what is that distance? It's from the middle of the paddle to the center of the ball. That's, again, half the height, 60, plus another 20, half the height of the ball. Okay, so this is the lowest y point. See that? This is the highest y point that the ball could be hitting. This is the lowest y point where the ball could be hitting the paddle. And then also, it's not just the y, because maybe the ball's over here. It is within the range. But it's hitting the paddle when this stuff is true about the y. It's between this range. And then also the x is like right here. They are grazing each other. This distance is true. Or smaller, like you could be trying to go into the paddle maybe. But that's when we hit that ball. Okay? So that's the secret. That's a lot of things. So like, what do we know? Like a bunch of things have to be true when the ball touches the paddle. So the ball touches the paddle. This gets really complicated, but this is what we need to know. The ball touches the paddle when? Well, what is true about the x when the ball is touching the paddle? They are right like this. They're just touching each other. So the distance between, in the x direction for the ball and the paddle, is 15 plus 20, so 35. All right? So that means they're touching the paddle when the, let's see, the ball's, like this is the ball's x, right? When the ball's x is equal to the paddle's x plus 35, right? That's when the ball's x is that amount offset from the paddle. So when the ball's x is equal to the paddle's x, paddle, that's a P, paddle x, so that's this point, plus 15, that gets us to here, plus 20, that gets us to there. Paddle x plus 15, half the paddle's width, plus 20, half the ball's width. That That's what's true in the x direction. So when the ball is x, right, the ball's x is here, when that's equal to the paddle's x, that's right there, plus 15 plus 20. See how that gets us right there to grazing the ball, or the ball grazing the paddle. Does that make sense? And then also the ball, hopefully, when it's touching the paddle, it's moving to the left. So it's possible, like in a frame, we're moving a little bit more just based on our offset amount, right, our direction amount. Maybe we try to go a little bit inside of the paddle. That's still okay. Just notice that. So maybe it's equal to or it's less than. Like it's a little bit less than, like just due to the way we're drawing frames, a little bit. We're moving it every frame. So that's what's true about the x. And that's not good enough, right, because the ball could be way up here and just grazing it still in the x direction, but like it's going to go through and we're going to lose the game. So we also have to consider the y. All right. So, okay, we need to rein in this ball. It can't be higher than, sorry, that's a bad line. It can't be higher than this, and it can't be lower than this. That's a y comparison. See that? So, all right, the ball's y. What should be true about that? Like, we got to keep it lower than this. So the ball's y should be less than or equal to, what is this highest point? Well, it's always relative to the paddle, remember. So it's always relative, like, here's the paddle's y, go half of that height and half of the height of the ball. That's the largest point. Right? It's always relative to where the paddle is right now. So the ball's y can't be any more than the paddle's y, wherever that is, plus half of its height, 60, plus half the ball's height. That would get you from here to here. That would give you that distance. That's as big. That would give you this coordinate for the y. Can't be any bigger than that. Plus 20. Does that make sense? It's got to be below that. But this is not good enough as well, right? Because that would be like, okay, it's okay if it's down here. We also have to make sure that the ball's y is bigger than, right? We have to rein it in, bigger than this. Okay? So the ball's y, very symmetric idea. Ball's y, it should also be greater than or equal to, all right? How do I calculate where it should be? It's always relative to where the paddle is. So it should be greater than or equal to the paddle's y. Paddle's y, that's there. Minus 60 gets me there. Minus another 20 gets me there. Minus 60, minus 20. That will give me this point, and we have to be above that one and below this one. That's what the less than and greater than are for. That's the x range, or sorry, that's the y range. And then the x range is saying the ball can't be any further than there. And that, taken together, you see how all three of those things must be true at once. Then the ball's hit the paddle. Can't leave out any of them. See that? Leave this one out, then like, okay, sure, I've hit the paddle when it's way over here. The x direction matters. Then also the y location matters, because like the ball could be over here. We haven't hit the paddle. It could have lost us the game. So we have to rein in the ball in the y direction as well. Okay? Like these are three different things that all need to be true at once for the ball to have hit the paddle. Okay, and that took a lot of thought. I had to make a diagram for that. Are there any questions about it? Does that make enough sense to us? Those are the three things that must be true all at once when the ball has hit the paddle. All right, so let's go and check for them. Just to make it easier on us, let's make sure, like, let's call this like condition A, condition B, and condition C. It'll be easy to check for each of those separately. Okay? All right, let's do it. Now we know. I'm going to make this a bit smaller so you can see all this still. So here's the bounce if hit paddle function. And so what do I need to check? I need to check if A, B, and C are all true. So I can make variables. You can make Boolean variables for each of these. So I can say, all right, let's call A a variable that's true whenever ball X is less than or equal to paddle X plus 15 plus 20. You don't even need parentheses. Like, take that, make it true or false, call it A. See how that makes it cleaner for us later? I'm like, all right, call condition B. That should be the result of checking whether or not ball's Y is less than or equal to paddle's Y plus 60 plus 20. And then one last one for, for condition C here. That should be true if ball's Y is greater than or equal to paddle Y minus 60 minus 20. Those are my three things I want to check here. And then the ball is hit the paddle if they're all true at once. So if A is true and B is true and C is true, then we hit. All right, so we hit the paddle if paddle if all three conditions are met, are true at once. It's possible because the x could be a little bit smaller. It's exactly grazing it if it's equal to, but it could be a little bit smaller because of the way that we're like moving a little chunk of animation every frame. If we tried to go past, right? It's possible to go past the paddle a little bit. Like our direction took us not exactly to here, but a little bit into here. We still hit the paddle. But we should never show the user that we went into the paddle. So if we tried to go past the paddle, move it to be just touching it, move the ball to be just touching the paddle. Hope that makes sense. And how do we do that? That has to do with changing where the ball is. The ball is x. If it ever got and tried to be smaller than this, if it was the less than part that made it true, just rein it back into exactly equal to that. That's exactly grazing the paddle there. Okay? And then, we have to bounce off. Bounce off by doing what? No, it's all very similar to what we did when we hit this was the right wall, right? It was the x offset that needed to change. So let's remember that. It's like here's the paddle essentially. Like we're hitting the paddle when the ball's moving in kind of this way. We're about to hit the paddle when we're doing this. And that means that our direction was a little bit left, so like a negative x, a little bit left, and then a little bit down. See that? That's what we need to do. And then we want to bounce off this way, which means keep our downwards direction, keep the same y offset, but negate the x offset. So we were going into the left, that's why we hit the paddle. We want to move off to the right. That will give us the proper direction to bounce off to. That's going to be negating that x offset. Oops. And that's right here. Bounce off by flipping x offset for the ball. And we had a variable for that, right? It was called ball x offset equals whatever it was times -1. So make it negative to bounce off in the other direction. Even if we were coming up and at it, we'll go off right and at it. That's the right and still up. Doesn't matter. What the y was, it's the x that needs to change. So that, I think, is what I wanted to say there. Because I'm setting these variables inside of a function, they're global variables. I have to mark, hey, Python, don't make brand new variables for those. I want to be able to touch global variables. Global ball x. If you're just using a global variable, it's fine. If you're setting it, you got to say this. Global ball x offset. All right? So yeah, every frame, we're going to move the ball a little bit. Like here's where it's supposed to be now. If we had a wall, we're going to bounce it off, rein it in. And then if we hit the paddle, that's separate from the wall, right? We can do it separately like that. Hit that, bounce off, change the direction, all that fun stuff. And then finally, after all that, we have a new direction potentially for the ball, which has been changed by one of these functions, maybe. And then also the ball has a new place to be. Bounced off a little bit, like reined it back in to be just grazing the wall, just grazing the paddle. Go to that spot that we've made those variables, and that should make it happy. Okay? Any questions about this bounce if hit paddle? That was very complicated to discover all the conditions that need to be true at once for the ball to have hit the paddle. But that led to this code. Does that make enough sense? Only if they're all true at once. If A ANDed with B, ANDed with C is a true statement. Results in true. Do I run all this? And it all works. All right, so let's see if I made any silly mistakes, because I think that's most of it. I've got a ball. I've got a paddle that I can move up and down. Wow. That is just so satisfying every time. And so it works. It'll even work if it's not always touching the ball, like just grazing. It doesn't have to all be on there. So that tippy corner needs to be touching it, and it's still happy. Even the upper corner should be fine, right? We'll test that. Nice. Didn't have to all be on the paddle there. And then we still need the option of losing the game. If we lost the game, we hit the left wall for real. Bam, and the game ends. That's so satisfying. Are there any questions about all these moving pieces? We separated as best as we could. Draw the bounding square, paddle stuff, moving up and down, ball stuff. It was really the ball that had the most work to do. It had to keep checking itself. Like, did I hit a wall? Did I hit a paddle? If so, bounce off. But yeah, it all ended up working out. You can change the complexity or the difficulty of the game by, remember this length? We were normalizing our direction, so it had a length 1 hypotenuse thing. And so that meant it was going to move 1 unit every frame. We can change that. We can like take that answer and multiply it by 2. Showed you that before, right? And this will make that hypotenuse length like 2. And then it'll move 2 units every frame in its random direction. So maybe that's a harder game to play now. I don't know, but it's different every time. We can sit down, the ball's moving a little bit faster, and it's going up and down in a scary way. Whee! That's kind of fun, and it's a new game every time. One quirk of the way that we're doing things that you can, I think there's a way to fix it, but if you hold in the key press stuff, you see that the ball moves a bit slower. It's kind of like cheating, but that's just a quirk of the way that Python is listening for our key press events. It's like it's forgetting to do other things. It makes the frame rate slower. But yeah, that is our game, and then you can watch it, and it works. And we'll hit that paddle with the ball, and then we can still lose the game if the ball hits that left wall, and I'll try to lose it right now. But yeah, it's just like every frame. What do? Draw a frame. What does that comprise of? Checking where the ball is, moving it by its offset right now, and maybe I don't want to. Oh man, I wanted to lose. And then if we had a wall, bounce off. So maybe we try to move too far. If we hit the paddle, bounce off. We learned what it means to have hit the paddle. Let's see if I can figure out where this thing is going to hit the paddle and try to lose the game for once. Nope, I'm losing. Oh man, okay. We just barely hit it still, but you get the idea. That's better. So now, if you miss it, you'll lose that game still. And yeah, as you saw, there was a weird quirk when it just like grazed the bottom bit, but that's more or less the correct thing to say there. You can play around with this, but that is the idea. Every frame, what do? Move the ball by a little bit, bounce if we hit a wall, using all of our if statements from before. That was all this fun stuff. And then if we hit the paddle, also bounce. And that was checking essentially similar things to checking a left wall, but had to do with relative to where the paddle was. The ball needs to be hitting the paddle, so it's relative to where the paddle is right now. Can't hard code anything. It's always relative. The ball's y should be relative to the paddle's y. The ball's x should be relative to the paddle's x, which is just super fun, super satisfying. And so yeah, you can change the complexity, the difficulty of the game by changing like where the ball starts. We try to keep it on the right half. You can make it harder by not doing that. Then also you can change the speed of the ball by multiplying this by some constant to change the number of units that the ball will move every frame. Okay, so that, I think, is what I wanted to say. Any questions about that? Alright, so that is Pong. That is Pong in Python. It's super fun, super cool, and that is your last programming assignment. So I'm not going to give you this code. Fun stuff though. I'm not going to give you the code. You'll have to watch the video if you want to recreate it. I do highly encourage you to try it yourself. Try just following the slides. See if you can recreate it. And then you can make it as fancy as you want. There's ways to add like text. You can add like a game over text if you want. You can change the color of things. Make the ball a circle rather than a square. But here's the idea. Like you can change the paddle. Let's actually do that. I think that would be fun. Change the, I don't know, I did pink and blue there. So let's make the ball blue again. That's the fill color, blue. We see how the ball's blue and the paddle's purple. That's fun. So yeah, that is the bare minimum that I want you to do. All right, so for this programming assignment, it's your last programming assignment. I'm not going to give you any more. I want you to just recreate this. You'll have to use the random module, the turtle module, all that fun stuff, and yeah, get everything that I did today working. Add on to it as much as you'd like. I think it would be fun. But this is your last programming assignment due essentially next week, right? Because that's the last week of classes anyway. But yeah, your submission, as usual, make a video, please. Explain your code to me. I want you to study it and understand it. Like show me that you're not just blindly copying the video. Like you actually understood it a little bit. And yeah, just give me a demonstration. Show me your beautiful Pong working. Feel free to add new things like a game over screen, 2-player mode. Make it your own if you'd like, but the bare minimum is do what I did today. Any questions about it? All right, fun stuff. So yeah, do attendance if you forgot to. I'll stop that in a minute. But I think that was everything that I wanted to say today.